Hi everybody. Tonight's video is going to be on relations and functions. We'll start with a general introduction to relations, and then we'll talk a little bit more specifically about functions, which are a type of relations. So relations are a correspondence between two sets, where the value of one set is dependent on the value of another. So we're going to have an output or a range is going to be what we're going to refer to one set as, and then the other set will be the input or the domain. So what we plug in for our input is going to affect what our output is. So the items in the domain are going to impact what the items in the range are. And we have all kinds of examples that we can use for this. One, just to think of in general, if we're like maybe comparing the age and weight of a group of people, we can think of the age as the input because that will kind of affect what our weight is, right? So if we are a little kid and our age is like 5, it's obviously going to be much different. The weight that we're going to have is going to be much different than when we're maybe in our 40s or 50s or something like that. So you can think of the way these two sets are related or the way they interact. There's always an input, and that helps determine what the output is. Mathematically speaking, there's a few ways that we represent relations. There's 3 that we're going to talk about specifically today. So there's what's called a mapping. We can also represent relations with a set of coordinate pairs. And then we can also represent them with equations. And whenever we're using either one of these, mapping, coordinate pairs, or equations, generally speaking, the x values are associated with our input or our domain, and the y values are associated with the output or the range. Okay, so let's take a look at an example of each one of these. So first of all, let's look at a mapping. And a mapping is a visual example of a relation where the values in one set are related to the values in another using arrows. So I have a picture here of a mapping. So I have, usually it's like a bubble here, and then each item in this set here is connected to an item in this set using an arrow. So it's like a picture of the relation. So the x values are over here, or think of it as our domain or our input values, and the y values are over here, the range or the output. And you'll notice there's only 3 items over here, there's 4 items over there. That's because the -2 and the 1 both connect to give me a 7. So if I was plugging in something for, if there was some sort of equation to represent this relation, when I plug in -2 or when I plug in 1, it would give me the same answer here. Okay? So that's what a mapping looks like. 2 bubbles with values, with the domain on this side and the range on this side, and the values are all connected with arrows. Okay, and if somebody asked me to write out the items of the domain, I would say -4, -2, 0, and 1. And if I had to write out the items in the range, I would say 3, 5, and 7, right? Because it's pretty clearly organized that way. Moving on to a set of ordered pairs, again, we'll just see it as a set like this. Each one of these is a set of ordered pairs. So this is an x coordinate and a y coordinate. This is an x coordinate and that's a y coordinate. This is an x coordinate, that's a y coordinate. That's an x coordinate, that's a y coordinate. So these are all ordered pairs. When we write out sets, we use these braces, and then each ordered pair is within parentheses, and then each ordered pair is separated with a comma, just like each coordinate within the ordered pair is separated with a comma, right? So this is how I would write out a set. Now remember, the x coordinates are always associated with the domain, and the y values or y coordinates are always the output in the range. So if I wanted to identify what the domain is here, I would look at all of my x coordinates, right? So in this case, it's going to be -1, 3, 7, and -1. You don't have to list the -1 twice, but so I can write this as a set. So I'll use my bracket. I'll say -1, I don't need to list it twice, 3 and 7. And we usually go in order from least to greatest. And then our range is going to be all of the y coordinates, so 3, 6, -4, and -2. So when I write out the set of all my values in the range, I'm going to do -4, -2, 3, and 6. And those are all my values in my range, okay? So if I have a set of ordered pairs and I'm required to identify the domain and range, I'm going to write a set of all of the x coordinates for the domain from least to greatest, and then for the range I'm going to write out the set of all the y coordinates. Moving on to equations. So equations, we've been working a lot with these already this year. So an example I have down here is y equals 3x plus 1. With equations, all the possible x values are the domain, and all the possible y values are the range. You might also see the x variable referred to as the independent variable and the y variable referred to as dependent. So that's just something you might encounter when you're reading about these or if you're looking in your textbook. So x is the independent variable and y is dependent. And that's because with an equation like this, the value of y depends on the value of x. So with something here, with y, I don't know what y is until I plug in a value of x. So when x is something like 1, I have to compute this to figure out what y is. So y equals 3 times 1 plus 1, so 3 plus 1, which is 4. So in this case, this would give me the ordered pair 1, 4. Okay, and so I could plug in every single point I can imagine for x and then compute that to get a value for y. And so that would generate a whole list of ordered pairs, and that would give me all the x coordinates that are in my domain and then all my y coordinates that are in my range. So when I think about this, right, I could list out all these ordered pairs, or I could make a table to find all the x values and y values. But generally speaking, with equations, what's going to happen with our domain is going to be all real numbers. Okay, so the domain will be all real numbers except where x gives us we could call it an unreal or an imaginary or undefined value. Okay, so this is going to happen rarely, but there's two scenarios where we are going to see it occur. So the domain is going to be all real numbers except where x gives us an undefined value. And I can show you two examples of that right now. If I had something like y equals 4 over x minus 3. I see this, I'm looking at this, and I think, okay, my domain is going to be all real numbers except for where I would have an undefined value. In this case, whenever I see a fraction, I know that I can't have a 0 in the denominator. So 0 in the denominator is one of our undefined values. So 0 in the denominator is not allowed, we'll say. So for this equation here, this relation, I would say the domain is all reals except for x equals 3. So since 0 in the denominator is not allowed, that means x equals 3 is not allowed. And that's because 3 minus 3 equals 0, right? So I'm looking at this denominator. I'm trying to determine what value for x would give me a 0 down here in the denominator, and I can see pretty clearly 3, because if I have 3 minus 3, that would be 0. So we'll have different ways to write this out. So if I were to ask you the domain of this relation, you would say all real numbers except for where x gives us an undefined value. So you would say all real numbers except for x equals 3. And we'll talk in class about some ways to write that, like using set builder notation, that sort of thing. The other scenario where we'll see an x value that's not allowed in our domain is when we have the an x under the square root, and we don't want to have any negative numbers, right? So if I have y equals the square root of x, let's say plus 4, okay? I can never have a negative number under the square root. That would give me an imaginary number. So all of these values that are underneath here have to be 0 or greater. So I start with the number that would give me a 0 down there. So I can say anything, we'll say less than 0 under the radical is not allowed. So less than 0 under the radical is not allowed. So just like up top here, 0 in the denominator is not allowed. We'll say less than 0 under the radical is not allowed. So now I'm going to look at this and I'm going to say which numbers give me 0. Negative 4 would give me 0, right? Because negative 4 plus 4 would give me a 0. And so that number is allowed. So x equals negative 4 is allowed under there. But if I put negative 5 under there, I would get negative 5 plus 4 would give me negative 1. That would give me a negative number under there. So anything, so x less than negative 4 is not allowed, right? Because all the numbers that are less than negative 4, so like negative 5, negative 6, negative 7, negative 8, that would give me a number that is negative underneath here. It would give me a number that's less than 0. And so that's not allowed, okay? So if I were to ask you the domain of this, you would say it's going to be all the x values, all real numbers except for x values that are less than negative 4. And we'll do some more examples like this in class. So moving on from talking about the 3 different ways to represent a relation, now we want to figure out if the relations are functions or not. And so a relation is only a function if every x value only matches up with one y value. So in our 3 representations for a mapping, if 2 arrows come from the same x, then that's not a function. Otherwise it is. If we have sets of ordered pairs and we see the same x coordinate used twice in the set, then that relation is not a function. Otherwise it is. And for equations, if we ever see the positive negative square root of x, or if we see something like a y squared, that's usually a sign that we don't have a function. So let's look at a couple examples of each. So if I have here, let's just fill in some numbers real quick. This is a function, right? So this is a yes. This side is all going to be yes. So it's a function. Over here, on this half, we're going to have no, not a function. Okay? So as you can see from this first one, it's okay to have 2 arrows going to the same y, but it's not okay, like we have over here, where we have 2 arrows coming from the same x. So it goes to 2 different values in the range. So if I have this x value, this input, and it's got 2 arrows coming from it, then that's not a function. Over here, usually we'll just have 1 arrow coming from all the x values, right? It's got to be coming from 1 arrow from each x value. But usually it'll be 1 arrow to each y value. In some cases, it's okay if 2 arrows go to the same y to be a function, but you can just never have 2 arrows coming from the same x. Moving down here to talking about the sets of ordered pairs, Both of these are okay, right? So these are functions, right? Because I don't see any repeats of x values. So I have 3, -2, 4. That's fine. They're all unique. -1, 3, 8, 10. Those are all different. Over here, this is not a function because I see -2 is listed twice. Okay, so I can't have that. Again, it's okay if like a y value showed up the same time. Like here I see 6 repeats, but I can't have any repeats in the x values for this to be a function. And then down here, there's just a couple examples of, yes, these are functions. It's okay to have something like 2x plus 7. It's okay to have x squared. But over here where I see the y squared, which when I would put this into y equals form, I'd end up getting something like this, where it's a positive and negative square root. And that would give us something like this, where there would be two x values that would have the positive and negative y value, right? So those are some examples of what functions can look like and what functions do not look like. So we'll be doing some problems in class tomorrow where you'll have these different representations of relations. You'll see mappings, you'll see sets of ordered pairs, and you'll see equations. And then we'll want to know, are those functions or not? And you'll also have to list out what their domains and ranges are. So be prepared to come do that in class tomorrow. Take good notes, and I will see you then. Have a great night.